Let's look at how to use the mean value theorem. There are three main steps to this process. The first step is to state the mean value theorem. Once you've stated the mean value theorem, you want to use the mean value theorem. So you need to show that your function satisfies the two conditions of the mean value theorem. And that because it satisfies those conditions, you have some sort of f prime of c is equal to whatever the particular f of b minus f of a over b minus a is for your particular function. And then you want to find the values of c that satisfy that condition and check to make sure that they're actually on your interval. So let's do that. We want to state and use the mean value theorem to find all numbers c that satisfy the conclusion given that f of x is equal to x cubed plus 4x squared minus 2x plus 3 on the interval from 0 to 1. So let's start by stating the mean value theorem. So if f is continuous, on the closed interval from a to b, and differentiable on the open interval from a to b, then there exists a number c on the open interval from a to b such that f prime of c is equal to f of b minus f of a all over b minus a. So we've stated the mean value theorem. After you state the mean value theorem, we want to use the mean value theorem for our function. So we want to show that our function is continuous and differentiable over the interval. So f of x is equal to x cubed plus 4x squared minus 2x plus 3 is continuous on the closed interval from 0 to 1. That's the interval that was given to us. And differentiable on the open interval from 0 to 1. Then we want to say why this is true. In this case, it's because f of x, so I can just say it is a polynomial. And we know that polynomials are continuous and differentiable over their domains. And that all real numbers their domain, so since 0 to 1 is real numbers, we're good. Because this is true, so there exists a number c on the open interval from 0 to 1 such that f prime of c is equal to f of 1 minus f of 0 all over 1 minus 0. Making sure that we're using the numbers for b and a that are specific to our interval. Okay, so we've started to use the mean value theorem. We know that there have to be numbers c on that interval such that the slope of the tangent at c is equal to the slope of the secant through 0 and 1. Next up, we want to actually find those values. In order to find the values of c, or perhaps just one value of c, we know there's at least one, we need to first find f of 1 and f of 0. F of 1 will be equal to 1 cubed plus 4 times 1 cubed minus 2 times 1 plus 3. So that's 1 plus 4 minus 2 plus 3, which is equal to 6. F of 0 will be equal to 0 cubed plus 4 times 0 minus 2 times 0 plus 3. I meant to write 0, but I accidentally wrote 4, which is equal to 3. So that means that f prime of c must be equal to 6 minus 3 over 1 minus 0. So that's 3 over 1, which is equal to 3. Now that we know that the derivative value that we're interested in, we need to actually take the derivative of our function. So f prime of x will be equal to the derivative of x cubed is 3x squared plus the derivative of 4x squared is 8x, and then the derivative of minus 2x gives us a minus 2. And we're interested in the x values, where this derivative is equal to 3. So now all we have to do is solve for x. So we can subtract 3 from each side. So we have 3x squared plus 8x minus 5 is equal to 0. Then in order to solve this for x, we can use the quadratic formula. Make sure that you always have one side equal to 0 before you use the quadratic formula. So that means the x values we're interested in are x is equal to negative 8 plus or minus the square root of 64 minus 4 times 3 times negative 5 all over 2 times 3. So that's negative 8 plus or minus the square root of 64. That's the ugliest, 64. Then we have negative 4 times 3 is negative 12 times negative 5 gives us plus 60 over 2 times 3. So that's negative 8 plus or minus the square root of 124 over 6. Now, we need to check to make sure that this is both of these numbers, both the negative 8 plus root 24 over 6 and negative 8 minus root 124 over 6 are both in our interval from 0 to 1. One of the easiest things to check in that is, since we have the 0, we want to make sure that we don't end up with a negative number. So we can just check our numerator to see if we get something negative. So the quick trick for this is that 8 is equal to the square root of 64. And the square root of 64 is less than the square root of 124. So, if we have a negative 8 minus a root 124, that means that we are definitely going to be less than 0. And if we have a negative 8 plus the square root of 124, that's definitely going to be greater than 0. Since a negative number is definitely not on our interval, that means that this is definitely not one of our C values. Since by the mean value theorem we have to have at least one solution, and the only other option is this negative 8 plus the square root of 124 for our numerator, that means that C must be equal to that negative 8 plus the square root of 124 all over 6. If we wanted to, we could simplify this. So this is equal to -4 plus the square root of 31 over 3.